Today's lab is resistor color coding. So we're going to have 10 resistors, okay? And by looking at these color bands on the resistors, we can tell what the resistance is. Now, if you notice, when you look at the resistors, now on this cardboard sheet, like the letter here and the numbers, this is the correct orientation. But if you look at the picture here, the bands are closer to one side. So when you're reading them, the band that's closest to one side, you're going to read from left to right. Okay? So what we're going to do is, for these resistors, again, the color bands mean something. And there's the numerical code here. So 1 through 9 represents a color. Then the next set represents a power and then a tolerance. Okay? So let's go through this example here. So this shows a resistor. So from left to right, the color bands are brown, black, red, and gold. Okay? So brown is the first band. So what I do is I look at my chart, and I see brown means 1. So I write down a 1. So that's the first band. The next band is black. So I look at my chart, black means 0, I write down a 0. Okay? So this is the first band, the second band. Now, then the next is times 10 to some power. Okay? So the third band, which is red, which if I look here, red is 2, this is where the 2 is. It's 10 to whatever power. So the third band is the power of 10. Okay? Now the resistors aren't exact. There can be a range, so that's called the tolerance. So then we have plus or minus, and then the third band is going to be the tolerance. So the third band here is gold. So now for the third band, I'm looking down here at the bottom. You see where it says the last 2 columns? That's the tolerance. So this is the tolerance. So it was gold, so it's 5%. So what that means is it's plus or minus 5%. How do we put that in a number? Well, what we do is 10 times 10 squared is 100, plus or minus 5%. So 10 times 100 is 1,000, plus or minus 5%. Well, what's 5% of 1,000? 50. So it's going to be 1,000 plus or minus 50. So the range of this is going to be from 950 to 1,050 ohms. Okay? So what we're going to do is, if you look at the chart, we have 10 resistors. First, I'm going to write the colors in order from left to right that I see. Then I'm going to write this. By using the color coding, I'm going to write what the range should be. The actual value, you're not going to write the number in between. The actual value is, what you're going to do is, you're going to take your resistors. Now, we already learned how to use a digital multimeter, so the setting is going to be down here where it says ohms. So I'll start off just like on the 200, which is the lowest setting. Remember, 1 means I'm out of range. Then I'm going to take my leads and I'm going to put them on the end. Now you see how I don't have, I have a reading. So it says 28.1, so my actual value would be 28.1, or whatever it is. It's going to fluctuate slightly because my hands are moving a little bit. So let's say it's 27.9. So my actual value, what I put here, this I would put like 27.9. Now remember, see where it says actual value? DMM stands for digital multimeter. So this is going to be the range. So all the values here, there's going to be an arrow. Okay? And then this is going to be the actual measured value. Now what you're going to do here is you're going to show the work for determining the range for the first resistor. So you see what I did here? whatever your first resistor is on your card, you're going to show the same work that I showed there. And then explain how you read the actual value, which we did that before, but you'll do that again. All right? And that's it.